In this video, I will demonstrate the difference between using inheritance and using composition. Sometimes a project will have classes that appear to be similar, but will have different behavior. In object-oriented programming, we often use inheritance to handle this. We create a base class that has the common behavior, and we put the unique behavior in the subclasses. But sometimes that can lead to code that isn't very clean. A different way to handle that is to use composition, where you just create a single class and you compose how that class acts, how the objects of that class act. For this example, we'll pretend like we're building a game and we have a monster class. Here's our very simple monster class with two properties, hit points and attack damage, and the constructor that takes into parameters to set the property values. After we create this class, our boss comes to us and says, now we need to create 3 different types of monsters. We're going to have monsters that attack by biting, monsters that attack by kicking, and monsters that attack by punching. Using inheritance, you might end up creating this monster class, which has the hit points, because all 3 types of monsters will have hit points. And then you would create a biting monster class that inherits from monster and has a bite damage property. The constructor here takes the hit points and the bite damage parameters, passes the hit points to the base class, and it sets the bite damage property value. The kicking monster looks the same, except it has kick damage. And the punching monster looks the same, except it has punch damage. So here we have the base class of monster with its 3 subclasses, biting monster, kicking monster, and punching monster. Of course, once we finish this, our boss comes and tells us some monsters can do 2 different types of attacks. So you could have a biting kicking monster, or a kicking punching monster, or a monster that does all 3 that would be a biting kicking punching monster. This is where we start to run into a problem. In C#, you cannot do inheritance from more than one class. So we could not create a biting kicking monster and tell it to inherit from biting monster and inherit from kicking monster. It can only inherit from one. So what we would probably end up doing, if we continue with inheritance, is create a biting kicking monster that inherits from biting monster, and it duplicates the kick damage property from kicking monster. And then we would create a biting kicking punching monster that inherits from biting monster, but duplicates the kick damage and the punch damage property from the kicking monster and punching monster that it cannot inherit from. So now our list of monster classes would look like this. It's starting to grow. I've added a monster factory class to make it a little simpler to instantiate monster objects. This just has an enum with the different types of monsters that are possible, and then a create monster function where I pass in the enum of the monster type up here, and it creates the appropriate monster. So for a horse, it creates a biting kicking monster. For Mike Tyson, it creates a biting punching monster, and so on. At this point, we have 7 subclasses of the monster class to handle the different ways that a monster could attack. But of course, the next day our boss comes in and says, we just realized that cobras spit. So now we need to add spit damage and create biting spitting monsters, and an orc will probably punch and kick and spit, so we need a new biting, kicking, spitting, punching monster class, and this is starting to get ridiculous. So instead of using inheritance, let's try using composition. With the composition version of the monster class, we're going to have one monster class, and we're going to compose the behavior. So we're going to say if this is a crocodile, the monster will only have biting behavior. If it's an orc, it will have biting, kicking, punching behavior. So here's the monster class. We have the hit points property like we did before, and the constructor accepts a hit points parameter and sets it to the property. But now we will manage the attack methods differently. What I'm going to do is I have a new property that is attack types. It's a dictionary of the attack type, this enum up here for biting, kicking, or punching, and the value in the dictionary is the integer amount of the damage. So if I want to say this is a biting monster, I'm going to call this new function here, add attack type, pass in biting, pass in the amount of damage it can do, and then I'm going to add attack type biting with the damage to this attack type's dictionary. If I want to create a biting kicking monster, then when I construct the object, I'm going to have to pass in biting damage and the biting damage amount, and the kicking damage and the kicking damage amount. So then the attack type's dictionary will hold biting damage and kicking damage. To make this a little easier to work with, I created a few new properties here. I have a Boolean, can bite, which looks in the attack type's dictionary and sees if it has an entry for attack type biting. The same with can kick, it checks to see if attack types has an entry for kicking, and can punch checks to see if attack types has an entry for the attack type punching. For the damage done by each method, I've got 3 new properties: bite damage, kick damage, and punch damage. And bite damage just checks to see if the monster can bite. So if we've added attack type biting to the attack type's dictionary, then it returns the value, which will be the amount of damage. If the monster cannot bite, then it will throw a new exception saying this monster cannot bite. And we have the same type of logic for kick damage, where we check to see if they can kick, then we return the value of the attack type's kicking, and punch damage, where we check to see if the monster can punch. If we've added if so, it returns the amount of damage, otherwise it throws an exception. In the previous monster factory, to create a horse monster, which can bite and kick, we instantiated a new biting kicking monster. The factory method to create a monster using the composition method is a little bit more complex because we are composing the behavior that the monster can do. So here our create monster function instantiates a new monster, passing in the hit points. So it would go through the constructor here, set the hit points, and set an initial value of an empty dictionary for the attack types. Then for the horse, because it can attack by biting or by kicking, I have to say monster add attack types, biting and the amount of damage, then add attack type, kicking and the amount of damage. This is the actual composition. Here's where we're composing how this monster acts. For an orc, we create a new monster and we add its 3 attack types. The really nice thing about this is if we need to modify some of the behavior of the monster object, this is when our boss tells us some monsters also need to do spitting damage because they spit poison. It's very simple to change. We would go into our monster class. For the enum, add a new spitting damage type. Create a new Boolean can spit property to check to see if they've added spitting behavior for this monster. Add a new spit damage property to return the amount of damage if the monster does spit. And other than that, we don't make any other changes. Then in our factory, when I add a cobra or a camel, which both can spit, all I have to do is add this new case to the switch to handle cobra, and we instantiate a monster and add its 2 attack types. And I change the existing camel that looked like this. Before it only did attack type kicking. Now it does attack type kicking and spitting. That's all we need to do to modify the behavior of the monster class. Something to keep in mind, just because I'm using a dictionary here in the monster class to hold the different attack types, you don't have to use a dictionary to be doing composition. The whole idea behind composition is just that you have one class and somehow you compose its behavior. In this case, I'm composing its attack type behavior, and this is a convenient way for me to do it. Depending on what your program needs to do, you may implement composition differently. This can also be very powerful if you combine it with the strategy pattern. So when you compose your object, you're passing in not just property values, but its behavior value, how the object is going to do something. I'll include a link below to show you a video on how to implement the strategy pattern in C#. But if you combine strategy with composition, you can end up with a very powerful class with some very clean, simple code. And also remember that just because composition is good in this case doesn't mean you always want to use it instead of inheritance. The two most common situations I can think of where you would want to use composition would be when you're trying to do multiple inheritance, because you can't do that in C#, and if you try to do it, the code just starts to get very messy. You have a lot of duplicate code, and that's never good. So you may want to consider composition in that case. Another time you might want to think about using composition is if you start having a huge hierarchy of a class that has a subclass, and that has a subclass, and that has a subclass. Really, any instance where your inheritance chain is starting to get complex or dirty and it just doesn't work correctly, start to think about if you can do it through composition. Here are two unit tests to show you a little difference between how it works when you use inheritance and when you use composition. In the inheritance version, I create a crocodile by calling the monster factory, tell it to create a monster crocodile, and when it returns this object, I can see if it's a biting monster by looking at the is. This is the data type. See if this object is this data type, which you can do with inheritance. But there's a problem when we try to instantiate a horse, which is a biting kicking monster, because it can only inherit from one class. A horse is a biting monster, but it is not a kicking monster. This test would fail. In our composition version, instead of checking the data type of the object, we look at the object and see, can it bite? So I create a crocodile, and this should come back as the crocodile is a biting monster and is not a kicking or punching monster. And when I create a horse from the monster factory, then it will return true for can bite and can kick, but will return false for can punch. If you have any questions or want to see the source code, I'll include a link to the support page on my site in the description below, or you can leave a comment here and I'll answer it here. Thanks.